Let's get rolling. Today we're talking about sensing our environment, and this is our very first lecture in that. So let's talk about the title of the course and explain what it means and why it's important to us. So what do we mean when we talk about sensing something? Anybody? What's that?
I'm trying to think, but it's just like, consider we use our senses for everything.
There you go, senses. You use your senses. What are your senses? Name a couple.
Sight, touch.
Taste, smell, sound.
Sight, touch, hearing, smell, taste. All of those are senses, right?
So data input.
They are inputs to our brain. Okay, those are inputs to our brain. Senses. Okay, so now we sense our environment with, to make that analogy go a little bit further, sensors. Hey, you made it. Awesome. All right, so, you know, if you watch science fiction, Star Trek or any of that stuff, you're probably familiar with these words for a long time, but they really do exist. But what we need to do is we need to look at the human element, which we've kind of introduced talking about our senses, and we need to talk about how do we do that if we're not human, if we're a computer? How do we get that information, that same type of environmental information into a computer? How do we do that? Mechanically or electrically or mechatronically? How do we get that information in there? That's really what this course is about, is what do we measure and how do we measure it?
So like, you need like scanners and scales and stuff like that?
That's part of it. Sure, we need to be able to measure if something is in a certain position or not. If it's not there, if we're painting a car, if there's no car there, we certainly don't want to spray any paint, right? So we need to know, is there or isn't there a car there? And sometimes this is simple, and everyone has seen this before. If you ever went into a little place called Radio Shack, you ever heard of Radio Shack or gone into a store? One of the things about Radio Shack is when you walk in, there's an invisible beam across the door, and when you walk in, it goes boo-ba. Tells somebody, hey, get on that guy, sell him something now, right? It tells you somebody's walked into the store. That's a sensor. It senses whether something has crossed a border, okay? And that sensor went into a computer somewhere that said, okay, whenever this sensor becomes true, I'm gonna send an output to make that boo-ba noise. Right? So there's a brain in there and there's a thought process called a program. And where does the brain get its information from? It gets its outside world information from sensors. Okay? So, with that in mind, what are some things that we can typically envision measuring? What types of things do you think a computer or a production equipment or a piece of equipment that's computer operated to manufacture things, what kind of things do you think they might need to be able to measure?
Weight.
Weight?
Size.
Possibly temperature.
Distance and color.
What else?
And also, because I know there are sensors that would be able to detect like something moving, so like you
Motion
can,
sensor.
yeah, motion, movement.
flame sensor in your furnace doesn't start blowing air until the flame comes on. And if the flame doesn't come on in a certain time, they don't wanna just keep it pumping gas into that plenum. So it has a timer on it. Eventually, the gas would get to such a concentration that the pilot light would blow it up, and then that's the end of your house.
What about like optical sensors?
What's that?
Optical sensors?
To sense what?
Like, you know how some stores will have the facial recognition on the cameras in case you've been kicked out or something?
That really comes as a combination
Yeah,
of these.
Okay.
So we can put that data together and use it as facial recognition. Color, shape, size,
like how.
position of eyes, position of things. In case of things like that, we need a camera,
Yeah, which
Right.
is technically also a type.
which is also technically a type of sensor.
Ultraviolet, infrared, there's sonar, light.
Light, I would just put them under,
Light,
I would put all those under the same general. umbrella.
let's actually go, yeah, no, you know what? Let's go with that.
Because they're all, like, it's all the same thing, it's technically detecting just light, but just a different type of light. So why write, 4 different types of sensors, light
Speed.
sensors? Speed, that is true.
That's under motion.
Yeah, speed.
Yeah, we'll keep that under
Well,
motion.
so it would be a differentiation because motion just means that something is moved, period, but to actually measure
Well,
the
if
speed,
you
has to
take,
calculate.
you see, say if you take like, a picture of one thing, and then you have to take another picture, like say like half a second later, you can determine how fast it's moving based on the, between those two frames.
Yeah, that's something we would probably do, like he said, mathematically.
Okay.
We can do a lot of that stuff mathematically because all of our sensors play into a brain, just like our brain does. We look at a coral snake versus a Arizona mountain king snake, for example. They're both yellow, red, and black.
But it matters
But-
what order it comes in.
Depending on which color is next to which color, it's either gonna bite you and you're gonna laugh at it, or it's gonna bite you and you're gonna go to the hospital. It depends on which color is next to which color. So we can take a picture and then use a computer to determine which color is next to which color. So we don't have to look at anything other than that. We just have to sense the actual physical change.
But a current sensor,
Current sensor?
like measuring, sensing electrical current.
Sense current, sense voltage.
Yeah.
And we don't need to find every one of them, but we get the idea. What about things like gas content,
Moisture sensor?
humidity? Perfect, I was just going there. In fact, pretty much anything we need to measure, we've developed a way to measure it. Okay, so in your kit that you have, I believe you have a temperature sensor, you have a distance sensor,
Yep.
you have a flame sensor, you have a motion sensor, you have a light sensor, I believe you have some type of humidity sensor.
There is a humidity sensor in there.
So you have a few different sensors in there that we can play with over time.
Technically, if you count the, one of the, button pad, there's a number pad thing, you technically also have a side weight sensor, cause it can tell if it's being pressured or being applied to it.
You could, and you could,
Technically, yeah.
you could reappropriate things to work in different ways that you might not normally understand. Okay, so all of these are items that can be sensed, and of course there are more of them. But let's look at the type of information. Let's first look at, let's pick temperature or light. Let's pick light. two different questions.
Yeah.
Is the light on or off? And how much light is there? This, on or off, is a yes or no
True or
question.
false.
And can there be represented by a 1 equals yes and a 0 equals no? So just a single bit can be used to represent the condition of that light. A 1 means yes, true. A 0 means false, no. How much light is there? Now we're going to have an actual value, which is going to be somewhere between 0 and 255.
And then I'm pretty sure in like the Arduino sense, they're technically done both through the number. It's just if it's 0, that just means there is literally no light. And if it's any other number, that means there is light there. So I'm pretty sure the Arduino one does it in just how much light is there.
Well, the Arduino could make that decision, but the other thing is
Yeah.
that right here, what you have is I'll do it in a different color just for fun, is you have a sensor. I'm not gonna do it in blue.
How about green?
Try green.
I see. I see.
Okay, technically there are two different terms for sensor and transducer, but a lot of people just kind of
Yeah.
interchange them. You know, nobody's ever gonna correct you if you use a wrong term. We'll all know what you
I
mean.
mean, usually if you have one, you're usually.
But transducer gives you an analog value that can go from 0 to 255. It can be any value in between.
Yeah.
A sensor gives you a single digit, a 1 or a 0, to tell you whether it's on or off. Is the light on? Is the light off? Or how much light is there? If you're growing pot plants, you need to know both. You need to know if the light is on or is off, and you need to know how much light is there, probably for what amount of time. So a lot of times these go together, and like Ari said, you can just look at this and say if it's anything above 0, then the light must be on. Or you could pick any number you wanted as a threshold for that.
Is the transducer like, so if you were to take apart like a PlayStation or anything with a laser read kit, there's on the, what do you call it, ribbon, there's normally a little thing with a screw on it, you can adjust the resistance, would that be a transducer?
I don't know, what kind of remote is it for an
It's,
Xbox?
so
I
it's like
know.
in a gaming console or a CD player or
CD
anything.
player.
The ribbon going into the laser, you see them on other things too on the motherboard, but it'll be a little plastic thing with a flathead screw, and you can adjust that, and it's to adjust the amount of resistance going into that part of the system.
I don't know what that's used for. It could be used to adjust frequency, it could be used to adjust.
Normally used to
You'd
adjust
have to read,
resistance.
you'd have to
You know.
find the original PlayStation documents.
Yeah, I don't know what that would
To
be
know what
used
that
for.
does.
I'm not familiar
Well,
with
yeah,
any
it
type
doesn't.
of those
It
consoles.
adjusts the resistance because there's a certain amount of power allotted, but if you turn the screw this way, it'll use less resistance, allowing more power to the laser.
Yeah, that resistance could change any number of different things.
Yeah.
We don't know, it's not a volume knob. We don't know what that changes. A resistor can be used in electronic circuits to change frequency, any number of different things, voltage, current, amplitude, any of those things can be ultimately changed by a resistance. So we don't know what that resistor is actually being used for without a schematic.
Yeah.
So that's why I can't answer that
you
question.
You might know it does one thing, but you don't know if it does anything else. That's
Yeah,
something-
I don't know. There's nothing wrong with that answer in our industry. That's what actually drives our industry. So that just means we'd have to go do some research to answer that question. So these things typically look different. Typically, the sensor looks like this. And the transducer looks like this.
Yeah.
Puts out 8 bits that represents a number between, somewhere between all zeros and all ones. So you might have a number in the middle somewhere that looks like this. So that's just gonna be a bit pattern that relates to the amount of light coming in. So with the sensor, it's either gonna come in as a 0 or a 1 bit. You can use that to tell whether the sun is up or not. Have an LED in your house that says, is it bright outside or not? This is gonna tell you how much light, because now you can get multiple ones and zeros that can represent multiple numbers. All right, the specifics of how all this actually works will be or has been covered in the digital class. But in order to understand the Arduino's function, we don't need to know what these mean. We simply need to know that it's going to break up the amount of light into a number of different available possible answers, where this is just going to tell us a yes or no. Okay, does that make sense to everybody? Let's talk a little bit about distance. In your Arduino kit, if you have it, you have something that looks like this.
The eyes.
You have something that has like a grid in here. Kind of almost looks like an old boom box or something. It's a little small. And it has probably 3 pins on the bottom, maybe 4. This guy, if I turn it sideways, looks like this. Sends out a pulse at a specific frequency and listens for the pulse to come back. You have that thing?
I'm looking for it right now. It says it is in here, right here, which doesn't work. Oh, there it is. Yes, there it is. Here it is.
So you'll be programming this. So how does this tell us distance?
It measures the amount of time it takes you to bounce back.
So if we send pulse, wait 1/1000th of a second, read the input, is the input high? If no, here? If yes, then we know how many milliseconds. Okay, so we're just gonna send a pulse and we're gonna wait a millisecond. We're gonna see if that pulse is returned. If it hasn't, we'll wait another millisecond. We'll continue to count off milliseconds until it returns. And then we'll know how many milliseconds it took. And then we could do some math based on the speed of sound to figure out how far away that is. Okay, so you will be making this program at some point. The beauty about doing these programs is that you can do them as they are written in the book. And then you can add features to them later. And that's kind of the way I tend to like to approach it. I actually have this in my car. My car has this arrangement. I got 3 lights on the back window of my car that light up progressively as I get back up closer and closer to an object.
Yeah.
A proximity sensor uses this same thing. I've got on the bumper of my car, I've got these little round things that are the sensors, and they can measure, they send and receive, figure out how far I am away from those objects. So I don't really need to add a backup camera, although I thought about it. But this does a really good job. I actually, when I got the car, I went out and measured to find out how far, when the first light went off in the back, how far I was away from the object. And when the red light goes off, you're about this far away from whatever it is that's behind you. So it's pretty accurate.
We used to have a drone that had those on all the sides of it.
Yep, drones have them too. I had,
Optical of one DJI.
yeah, a little Spark. I had a Spark.
I had the Maverick 2 Pro.
Yeah, those are pretty nice. I had the Phantom way back when, and then got a little one of those little pocket Sparks that are really handy. But I've kind of given up on that ever since it became legally difficult to maintain that. I don't want to deal with,
Having to register it with the FAA and stuff.
yeah, and having to deal with all that. I mean, a lot, you know, if you know physics, you realize that a lot can go wrong real fast.
Yeah.
You know, you want to go down and fly around, take pictures downtown, and your drone flies into a plate glass window. Oops, usually no big deal, but if the window breaks and falls on people down below, you're done.
Yeah.
So I don't want to take that risk. You know, it's just not for me.
The other thing is that the air base nearby really doesn't like people flying drones too high.
No, it's true.
So
Yeah, I used to live over by the Capitol building, and where I lived was actually in a no-fly zone. And so I couldn't
the
even
majority of
fly my,
the majority of Tacoma is just a big no-fly zone.
I live in Olympia.
So
You know, we got a couple airports in the Capitol building and stuff out there you can't fly around.
yeah, which for good reason.
Yeah.
This is an important concept.
Yeah.
Okay, the Arduino has no idea what's hooked up to it. All it knows
Take info from this spot.
is that every once in a while, something connected to one of its pins gets a pulse. It's going to get the same pulse no matter what actual sensor I have hooked up to it. If it's a light sensor, it's going to get a 1 when the light's on. If it's a sound sensor, it's gonna get a 1 when there's noise. If there's a motion sensor, it's gonna get a 1 whenever somebody's moving around. It has no idea where that 1 is coming from. How do you give it that information?
Yeah.
You have to program it to that pin, right?
You're gonna write a program that's gonna tell the Arduino what it's doing. But does the Arduino actually know what it's doing?
Nope.
No, it's just doing what you tell it to do.
All it knows is you told it to get a signal, it takes signals from this pin, do this to it, and then put something out on this pin.
If I have a transducer that sends in a bunch of pins together as a value, and then that number is displayed out here on a 7-segment display. Here's 7-2. So if 7-2 is displayed on that, based on the input here, and we have a display and it says degrees Fahrenheit on the label that's underneath the display. What happens if I hook up a different transducer that measures pressure?
It's gonna do the same thing.
Is the Arduino gonna flunk that out because it's hooked up to the wrong sensor?
Nope, it's gonna take whatever's there.
It's gonna
Do
take
its
whatever's
thing
there
and put it
and
on
it's
the
gonna put it out on the display because it doesn't know and it doesn't care what you're actually measuring,
Doesn't know.
right? So all of the transducers, whichever one you wanna work with, they're all gonna put out a similar type of information. Every sensor is gonna put out a 1 or a 0,
That's how I was getting this out.
right? There's your 7-segment displays.
There's also a single one display variant too.
Yep, yeah, and you've got a couple of other types in there too. So anyway,
These are just the nice.
the Arduino, this actually makes life easier in a lot of ways because it means that we can use almost the same program to represent a humidity transducer or a temperature transducer. The program is going to be virtually the same because the data coming in looks the same, it's 1s and 0s, and the data going out looks the same, it's also 1s and 0s. So what label you put down here matches which transducer you're using. Okay, so very similar program, different sensor or different transducer is going to give you a different output. I know that kind of sounds like a duh, but it also needs to be understood because if you've already written a program to measure temperature, then you've already written a program to measure just about anything else, right? Copy, paste, and change. All right, remember we had this discussion last time we met about using your education versus solving the problem? Remember that discussion?
Yep.
That a lot of times it's like, oh boy, I went to an Arduino class, I can figure this out, and then you spend 3-4 days trying to write the program and you get it working, and it's like, I feel good, right? But in business and in our industry, we're gonna go look for a similar program first on the public domain and see how far off it is from what we need, and then we're gonna modify the program to work to fit our use. And if we can do that faster than we can start from scratch, then we saved our company and our customers money.
And also time, which is money.
Well, time is money. All right, so one of the things that you have to become familiar with and you have to make sure that you understand is that unlike the way it was and the way it may be in other people's classes, if you go out and look on the internet and find a program that's similar and you make it work, I don't consider that to be cheating. Okay, I don't expect you to write the entire program. If that's what you want to do and if that's what you want to learn and that's how you want to approach it, feel free. But all I care about is the results, because in industry, that's all my customers care about is results. Okay? So make sure when you write these programs that, and we'll talk about this later, we got to talk about documentation, and it is on you to understand how these programs operate.
Yeah.
So if you're going to copy a program, the deal we have is that I'm okay with you copying that program, but if there's a question about that program and I ask you that question, I would expect that you know the answer. Okay, does that seem reasonable?
Yep.
All right, anybody have any questions? What time is it?
It is
9:36.
36.
What is it?
9:36.
All right, we are done. Anyone have any questions that I can answer at this point? All right, so today we introduced what sensors are. We introduced what transducers are. We talked about the differences between them. We talked about the different things that we can measure using sensors and transducers, which basically takes care of, in a traditional drawing, the left hand side of our Arduino. Next time,
Yep.
we'll discuss a little bit about the outputs, because that is not part of sensing our environment. So in our next Arduino lecture, which will be Wednesday,
Wednesday.
we will talk about the output side, which we call field devices, output field devices, same as PLCs. What do we use this information that we're getting at the input to actually control, and how do we control it? Okay, so we'll look at the inputs in this class, we'll look at the outputs in the other class. All right, any questions? Again, any questions? One last chance before I click the record button off.
Just to take my curiosity, would a weight sensor and a pressure sensor be the same thing?
I guess that depends on how you define weight. On our planet, yes. But somewhere else, it may not be the case. Because weight is dependent on gravity,
Yeah.
right? So less gravity, less weight, same size. Does that make sense?
Yeah.
Yeah. So yes, it's the same thing. We measure this way. Why do I keep using the blue?
I was just thinking, like, you got a PSI sensor and a compressor. Even if that sensor is facing up, it's not based on gravity. It's based on atmospheric pressure.
You got lines of resistance here, right? If I lay that flat, looks like that. If I put something on it, it bends this, which pinches those wires and causes the resistance to change.
Yeah.
And that way I can measure weight. This is actually what's called a stress or strain sensor. We'll talk more about those later. Okay, we can use that to determine either the presence of an object or how heavy that object is. Again, sensor or transducer. Sensor just tells you it's there. Transducer tells you how big is it, how much does it weigh. All right? All right, we'll turn off the recordificator.